All right. Everyone have it turned in? Okay, cool. I just want to point out again here the skills project, right? So we're at the point where the static routing, it's gonna, did it already close? Let's see. April 9th is the last day. So a lot of you have turned in your static routing, maybe all of you have. And there were just a few little problems, so make sure you go look at the view feedback, okay? Some of you just have to check your addressing. Some of you have used the wrong format. So there's not a lot to take care of, but there's a little bit. So just make sure you take care of it and get it turned in before the 9th. And then the packet tracer part, that's also due on the 9th. Okay, so the packet tracer, you've got everything working. Now you're just adding the static routing so that we can have both sides talk to each other, right? Right? Yes? Okay, because we've got these two routers, and as of yet, right, these aren't able to talk yet. But once you add that static routing, it will be able to. This week, we're finishing up DHCP v4. Next week, we're doing DHCP v6. And so that's the next part of our skills project, part 5, is DHCP and host support. So that's due the 16th, okay? So after this week, you should already have some of the ideas and commands ready to go for your DHCP. So you might want to work on that. And then next week, we'll be talking about DHCP v6. Now I'm going to publish this. So notice you're going to be turning in lab commands, okay? And the lab commands are nothing more than copying and pasting the part that you've been putting into the boxes, the answer sheets, okay? Make sure you do that lab that we did on Monday and get that done. Because, well, do it, but also the other option is you might want to consider wiring up your lab, your skills project. That particular lab is really close to the skills project, right? It's just a couple of things missing, you know, as far as the VLANs go and stuff like that. I want to make sure that you've done something similar where you're pulling it all together, okay? And then also, one of the tasks for you to be working on this class, just through the whole class again, is just seeing this and how does this fit into the real world? How is this really, if I were to be opening a small business, or if I already had a small business and I was opening up another department, or if I was going to be opening up another branch office in a different city? That's what we're doing. So you also want to just think about, like, how does this fit into what I might be doing? Okay, instead of just going through the motions, think about, like, how is this real? Okay, so I'll go ahead and publish this and we'll put a due date on it. You'll be building your skills project on the last day of class, proving that it works. Okay, so you saw how, I think, Chase, you got done with the lab on Monday, right? So that lab, we had 2.5 hours, right? And you're the only one that finished. You got halfway through? More than halfway, okay. So that's good though. So, but again, I want you to think about this, right? On the last day of class, you'll have 3 hours to build your lab, right? So that's why you want to maybe think about pre-building this, coming in on a Saturday, coming in on a Friday, and seeing how it's going to go, so that if you run into any trouble, you already can work out some of those kinks. Because chances are, even if you get it working in Packet Tracer, does Packet Tracer always work exactly right once you actually go cable it up? No, sometimes there's just a little something, right? So again, I just want you thinking ahead. It's the same thing. Let's say you were getting paid $15,000 from a customer. right? And so normally what would happen is, you would negotiate, okay, yeah, I can handle that contract for you, blah, blah, I'm going to charge $15,000. I'm going to, purchase the equipment, make the plans, blah, 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 blah. And then I'll be doing your connections between Friday and Saturday. I expect being on site, for 6 hours on Friday, 3 hours on Saturday, whatever that looks like, right? So when you show up, then do you want to be like, oh gosh, I know I've been here and you've paid me that $15,000 already, but I don't know, I just couldn't get it working. I'm going to have to come back next week and I'm going to charge you for those days. Is that okay? Do you see what I'm saying? So as a professional, right, I want to prep that network because it's best for me too, right? It's best for me because chances are that customer's not going to pay me. I'm going to have to come back on my own time and get that working. And now I'm outside of my contract time. Okay? All right. We are talking about DHCP today. And let's see. Let me get this. And again, it's like a lot of the different protocols that we've dealt with. It's not that it's so difficult to understand as much as you just have to make sure you get all of the steps and you don't miss any of the steps, right? Let's see. And I think one of the things that I like about learning about DHCP is it kind of solved a mystery about, well, how do these devices get IP addresses, right? What about the default gateway? How does it know all that? Well, now that we've done the commands, we can see, right? We give the router or the server all of that information so it has it. Okay, I'm going to hand this out. And there's a question about a review of the OSI model and the PDUs. And then I want you to fill out the DHCP part. If you know the DHCP v6, you can fill that out too. But if not, do at least the DHCP v4 part. Okay, and I don't want you to use any notes. Just do what you can to answer these without notes. No notes. We're going to go over it together, so if there's something you don't know, you won't be stuck on it, but I want to see how far you can get without notes. And even if you don't know the answer, see if you can muscle brain your way through it. Yes. Uh-huh. Yeah, this is the client, so that's the computer. So what is the DHCP message type? Write it right there on that line. So see when it's requesting it's asking for an address from the server. So what is that message type? And then how is it sent? As a unicast message, a multicast message, or a broadcast message? So everybody see how that first, the way it works, right? So here's the client, and it's got this. So the first thing it wants to know is, what's the DHCP message? You put that here. The next thing is, what is the address type that it's using? Right? So, and the address type, that's going to either be unicast, multicast, or broadcast. Okay? That's a weird pen. So the DHCP V6, if you know it, that's great. If not, I want you to, you'll be bringing that back for next week. But let's get through the DHCP V4, answer those. Do the OSI model and the PDUs. Hopefully we'll all get 100% on that part. When you're done or you're as far as you can get, pop your hand up. Okay, okay. All right. Got it? You don't have the OSI model? All people seem to need data processing? Okay, I thought so. Don't send pets for beer? Yeah. Depends who you are. I don't like beer, so for me, don't send pets for beer works. Okay, so these were the highlights for our Module 7. How do devices get addresses? So there's two ways when we're talking about IPv4. The first way is statically, we just go in there and assign them, right? And then the other way is, yeah, DHCP, dynamically assigning them. One of the commands that we have to do when we're setting up DHCP is to create an exclusion list, right? Why do we need to do that? Yeah. Yeah, like I might have some statically configured addresses and I don't want them to be part of my what? I don't want them to be in my pool because there could be a what type of address assignment? What would that cause potentially? A duplicate address. It could potentially cause a duplicate address. So, you know, if we set up typically we're going to set up a static interface address on our router to function as the what? Yes, but if I have my router and it connects to a LAN, this interface is the what? The default gateway. And normally we would statically assign that address. So we want to make sure that we include that in our exclusion statement. Also a printer, right? Like we don't want to have our printer randomly getting addresses every time it goes on and off, because our devices need to know how to find the printer. So it's important that we have these exclusions for that reason, okay? Let's see, then we'll talk about the lease process. What are the ports associated with DHCP? Someone raise your hand. Adiel. 67 and 68, and then we'll look at the commands. We'll do some show commands, when and how to configure a helper, and then we'll also look at the helper. I did have one question, I think, on the survey about the helper address, so I've got a little bit of help on that. That should make it a little bit easier to set up the helper. And another question that I thought was really good is with inter VLAN routing, Chase had asked, right? And I think the lab addresses that, doesn't it? Yeah. Yeah. So if you have sub interfaces and you're doing inter VLAN routing, and let's say we had 6 separate VLANs, how many pools do I need? 6. Yeah. Each one of them just need their own pool. Now I'll tell you something else, and I used to do this on my skills projects. Maybe we will in 160. So not next week, but I think the week after we're going to be talking about FHRP, or maybe next week, first hop redundancy protocol. And that's when you create redundant default gateways. That way, if one of them break down, you have another backup default gateway. And that's called first hop redundancy. Well, if you're going to run first hop redundancy and you've set your DHCP server up over here, you may have to also set up a redundant DHCP server over here. And it would just be the exact same commands. And it doesn't matter which one responds. It's just a first come, first serve. So whichever DHCP server receives the request first is the one that would give out the address. So we can set up redundant DHCP servers just like we set up redundant switches or redundant, we do Ether channel for redundancy. We can do the same thing with default gateways called first hop redundancy protocol, and we can do the same thing with DHCP servers. DNS servers, like there's almost always more than one DNS server, because if one were to go down, your whole network would go down if you don't have a backup, right? Because if your DNS server is not functioning to take the Cisco.com and translate it to an IP address, it can't do anything. So we pretty much have redundancy of all of the different protocols, okay? All right. We know it's DHCP, we have manual, okay. So the benefits of DHCP, really the main thing is it's easier to manage your network, especially if you have a big network. I mean, even at my house anymore, it would be difficult to not be running DHCP. I've reached a point where I probably have like 17 or 18 devices in my house. Back in the good old days, we had a computer, maybe a printer. But now my air conditioning unit, my cameras, my alarm system, my mom just bought she doesn't even know this, but she bought a washer and dryer, and they're Wi-Fi enabled. You know, she's like, why would I need this to be Wi-Fi enabled? I'm like, well, what if you're out and about and you wanted to start the wash machine? She's like, why would I want to do that? I'm like, I don't know why you would want to do that, but what else? I mean, I have 2 TVs, I have a Kindle, I have my cell phone, I have 2 laptops. I mean, what, you know, so even that would be very difficult to manually and statically go assign my IP addresses. So DHCP comes in handy. Let's see, time saving, right? The leases are all handled. Okay, so this is more or less our homework or our class activity that we did, right? The lease process. So normally what would happen is you turn on your computer and the first thing your computer says is, oh, I need to start gossiping, right? I want to start talking to everyone else. And in order to do that, I need to have an IP address, okay? Now, one of the things on the lab that came up was, what if it can't find a DHCP server, right? So you're going to get an error message, but the computer, it still wants to talk. So it's going to give itself a what, Umberto? An APIPA address, right? APIPA, and APIPA address. When your computers can't find a DHCP server, they're going to give themselves a 169 address because they want to start talking, right? Now they can't get on the main, they won't be able to get on the main network, but they'll be able to talk to any other device that has a 169 address on your network. Okay? Do you have a question? You have a quizzical look. Okay. All right. So the client comes on and it does what kind of a DHCP message? It needs to discover, right? It says, I want to discover an address. I want to discover. Now, what address does it use to send that request? Nope, not the MAC address. It does a broadcast, right? It's going to broadcast it because this client has no idea where the server is. And so it's just going to broadcast it to everybody. You can even make your host, you can turn a host into a DHCP server. We could download the software and have this host function as a DHCP server. So it just broadcasts it out. Okay, now let's say you did have more than one DHCP server. That's okay. It's a first come, first serve. So whoever the DHCP server is that takes that request is the one that will respond. Okay, so it makes a request for an address doing a discover, and that's a broadcast message. So that's a 255, 255, 255, 255, right? All right, so the server receives the discover message, and now it says, I'm going to think about this, and then what does it do? It responds with an offer. It responds with an offer. Now, what kind of address message is it going to use? Unicast. It's going to be a unicast. Now, can anybody tell me what the unicast address is? Well, that's a MAC address. It's a weird address that you might not think of. So just, it's not the MAC address. It's not 255, 255, 255, 255. And this client doesn't have an address yet, right? So when it does the response, it has to use an address. Well, it's not really a private address. It's just, think of it, it's a weird address. Yes, that's exactly right. 0.0.0.0 is the address that it uses. It just, since it doesn't have one, the server needs to put one in the header, in the IP header, and so it just plugs 0.0.0.0 in there. Okay? So now the client receives the reply from the server, and the server says, so I have one to offer you. And so what does the client say? Oh, yeah, it's like, hey, I like your offer. I'll go ahead and request that address. Okay, I'll go ahead and request that address. So again, what kind of a message is it? It is no, it is not a unicast. It's a broadcast. It's still just broadcasted out. It's still just broadcasted out to everybody. Because even if it's responding to that particular one, it's letting any other multiple DHCP servers know I'm going to go ahead and accept this one. Okay? So it's still a broadcast. It's still a broadcast. Okay, so this is making the request. I'd like to request what you just offered me. So it's still making a broadcast, 255, 255, 255, 255. The server receives the request. Okay, now think about this for a second. The client has looked at its address, has looked at the address, and it says, I'm going to request it. Does it have it yet? It doesn't have it yet. It doesn't have it yet. Okay, so now what does the server respond with? An acknowledgement, right? An acknowledgement. And what address is it using? What address type? A unicast. And what's the address it's using? It still uses the 0.0.0.0 because this client doesn't actually start using its new address until it receives the acknowledgement that it's okay. Yeah, so it's going to get the acknowledgement, and now the client finally gets its own address. Finally gets its own address. Make sense? Okay, good. Let's see. And then if we want to do a lease renewal, if you were to look at your address today and you had compared it to an address like yesterday or Monday, it's probably the same one. Devices try to keep their same address. It's just less resource intensive for it. Okay, so if you come back into class, you turn it on, the client's going to try to get its address back. What does it ask for? The client sends a what? Okay, and what address type? A unicast, right? Because wait a second. No, it's not a unicast. It's still a broadcast. Here, let's look. Maybe I'm wrong. Yeah, it's a unicast. It is a unicast. It's not a broadcast. So you said yes, it's a unicast. See, I keep thinking that it's always a broadcast because there might be multiple servers, but it's going to ask the same server. Then it sends a broadcast. Right. Yeah. That one could be a little confusing, right? Okay, so client turns back on. It wants to try to get its same address. It sends a unicast to the same server that it asked for the first time. Okay, now how does the server respond? With an it's a special type of acknowledgement. Right? Exactly, the DHCP. But I think it puts a special type of acknowledgement in there because it's like a renewal request. And now notice this time it's a unicast, right? This is going to be unicast. But what unicast address is this one going to? That I don't know. I would think it's going to the address. But does it still have? Yeah, because it's a renewal, right? So it's got the address and it's trying to renew that same address. Yes, so it's going to go to that address. Okay, that makes sense. That makes sense. Okay, let's look at some ports, right? Now the ports are important in the same process, right? The same process. So The DHCP v4 message format. DHCP messages are encapsulated within the what kind of transport protocol? UDP or TCP? UDP, right? UDP. Because it doesn't really, first of all, think about if it were TCP, wouldn't it take forever to get an IP address? Because what does TCP do first? That's not. It establishes a connection, a dialogue, right? It creates the whole dialogue so that it can say, hey, are you there? I'm here. Okay, great. Can we make a connection? Yes, we can make a connection. Right, so just that process alone takes a lot of time. So it uses UDP so that it can get the address much faster. Now, what if it doesn't connect? It doesn't care, it just asks again. That's why it doesn't really care if it's reliable or not. If it doesn't get an address the first time, it's like, okay, well, I'll just send out another request. I'll send out another discover, so it doesn't really care. Messages sent from the client use what UDP port for the port and destination port? So we know it's 67 and 68, right? So the client, what's the source port of the client? 60, I think it's 68. I think it's 68. Which was, you said 67, you said 68. Who has it in their notes? I think it's 68. Is that what you have in your notes?
No.
Okay. Yeah. Yeah. Client uses 68, server uses 67. So the client, 68 to the destination port of 67. Message is sent from the server to the client. So the server's source port is 67 and the destination port is 68 on the client, right? That's just something you have to memorize. The way that I remember it is I feel like it's the opposite, because I always think of, we start with the discover, right? The discover, which is on the client side. So to me, I always feel like it should be 67. So I've told myself it's always the opposite of what I think it should be. That's the only way I can ever remember it. All right. And this will definitely be on the CCNA. They always ask a question like this on the CCNA. You'll have a few questions about DHCP on the CCNA exam. Okay, so then the commands, you practice these hopefully on the lab, and if you haven't done the lab yet, or that part of it, you will get to it. These are going to be the exact same types of commands that you're using on your skills project. So the skills project really shouldn't throw you, okay? Really shouldn't throw you. All right, so first of all, we've got to exclude the addresses, which we've already talked about why we would need to do that. And usually add a few in, right? Add a few in. Like here on campus, we exclude like the first 30 or 40, because who knows? Our projector has to have a static IP address. Then we added the Lumens camera. That needs a static IP address. So we just go ahead and exclude a big chunk of addresses. So the bigger your network is, the more you might want to think about what you exclude. We're dealing with pretty small networks on our labs, right? So the 10.1, that's probably my default gateway, right? The DHCP excluded address 254, maybe that's my switch virtual interface, right? And since it doesn't fall between 1 and 9, I have to do it on a separate statement. When you're naming your pools, make them make sense. I can't remember if on the skills project we told you how to name them, but you want to make them make sense so that when you look at them, it gives you some indication, oh, that's for VLAN 11, right? Or that's for the human resources. Like, help your future self know what your DHCP pool is for. Okay, now the network address, it needs to know the network, right? the default router. So we're telling it which one of these excluded addresses is my actual interface. If we have a DNS server, sometimes you do, sometimes you don't. Now, I know that this says that the domain name is optional, but I always recommend you have a domain name. It just makes things run a little bit smoother. At this level, we're not doing very much added security or added encryption, but as we start to do that, you need the domain name. So it just helps. Okay, so again, it is straightforward. You just can't miss any of the steps. I'm sorry, ask that again?
How the network identify the pool, like you have two network, and then you have a two pole in the outer two. But how the network gonna know this address is mine, this is for other network.
Okay, I'm not 100% sure I understand your question, but this network is what is telling, and you're in the DHCP mode. So if I'm understanding what you're asking, this network command right here is attached to the DHCP, and that's how it knows what network it's associated with. Now, if you have additional exclusions, right, well, they will also know it through the network.
I talk about the pool because I'm confusing about that.
Okay.
Because in my mind I was taught the pool is the name, it's just the name.
Okay.
But when I come right now, I see it's not just a name. It is something. It is something else. How the network identify that? Because in the research we did, the name of the VLAN was just VLAN 20.
Okay.
But when we configure, we write to VLAN 20 cells. That's how the network identify. This one is in my DSCP, and then that pool is for another network.
Is this in a lab that you have a question about?
No, it's just something I have in mind.
I mean, so here we have 192.168.10.0 and it's a /24. Okay, so we would know that these addresses are part of that network. Is that what you're asking? Okay. The pool.
The pool, yes.
Okay, so do you mean how does this network know that it belongs to this pool?
The computer,
Uh-huh.
how the subnets know this one is my address, and then this computer knows this one is not my address, like we are in the VLAN.
Okay, so if this were on VLAN 10 and this was on VLAN 20, because of how you have it plugged in to the switch, and you've told the switch what access port it belongs to, VLAN 10 or VLAN 20, and then that connects up to the router, and that's how the router knows.
Yeah, that's mean the pool is just a name, like the words pool name VLAN 1.
Yes.
Just a name.
Yeah, it's just a name. It's really using the network, okay? So I think I might understand a little bit what you're asking. Yeah, the name is just a name. Okay. Router, right? So VLAN 10, VLAN 20. We had to tell this, right, that it belongs to 10 because we did switch port access mode, switch port access VLAN 10, VLAN 20, and then it's connected up here to the sub interface. And that sub interface is encapsulated as a .1q.10 and a .20, right? And they have their default gateway address. And that's how it knows what pool to pull from. So they all link together. But you're right, the pool name is just a name. And that's why it's important for us to name it something meaningful. Like if you just say pool 1, pool 2, pool 3, you're going to have to do a little bit of work to figure out which VLAN it's actually a pool for. So you should make your DHCP pool name a meaningful name. Pool VLAN 10, pool VLAN 10 HR, pool, something like that. Okay? Because it is just a name. It's just a name. Okay, yeah, but it's always using the tags to figure it out. It's always using that tagging. That's why that concept of tagging is so important for us to understand. Okay, but it's just a name. Okay. All right, so questions about this? And did we answer that? Okay. All right. What can be done to verify the DHCP client? What show command?
Like on the client?
What can be done to verify? Yes, on the client. Yes. Mm-hmm. Right, and it will tell us whether the address was pulled dynamically. Right, so we can see here's our IP address. And notice it's 10.10. Well, where did our exclusion end? It ended on 9. So this was the very next address, right? And it's telling us that we're using a DHCP server. DHCP is enabled. So we're good. Okay. How do I verify? What's one of the show commands I could use to verify it on my device, on my router? Yeah, but that doesn't verify. That verifies that there's commands in there, but it doesn't verify that the DHCP is functioning. Show IP DHCP bindings, because then you can see the dynamically assigned address and what it's bound to, what it's been bound to. So show IP DHCP bindings. There's that. There's our DNS server. Let's see. There's our domain name. What show command can be used to verify MAC addresses are binding? So here's that one we just talked about. Show IP DHCP binding. So see, I can look here, and if we did an IP config all, we'd be able to see this MAC address is associated with the host. So this is the command that will tell us on the router that it's making a bond. It's found a device, and it's given it an address, and then it's connected them. It's bound them together, okay? A couple of other helpful commands: show IP DHCP server statistics, and then the show running config. The only problem with this is it shows us the commands. It just doesn't prove that it's working. Okay, let's see. This is ipconfig release, ipconfig renew, right? Release, renew. Okay, so let's talk about helper addresses. Now, I went kind of easy on you in the skills project that you only need one helper address. Okay, because sometimes you need to have multiple helper addresses if you have more than one hop, which is pretty common. You might have 2, 3, 4 hops to where your DHCP server is. That means each one of those hops needs to have a helper address. Okay, so the first thing I want you to think about is when the client asks for an address, what type of message does it use? A broadcast discovery. Okay, so let's just think about this. Let's add another router here, and let's add even another router, okay? So my device, it's asking for an IP address, and my DHCP server is a couple hops away. This does a DHCP discover broadcast. So it gets up here and it hits my, what? My default gateway. Now, there's no DHCP server here, okay? But as long as we have a helper, we'll be able to figure it out. But let me ask you a question. Does this router and this router send broadcasts? It doesn't, but yet DHCP relies on broadcast messaging. Whenever you have a protocol that relies on broadcast messaging, that's when we need a helper address. So even though the first time we're learning about helper addresses is as it relates to DHCP, there are other protocols where maybe they need to, that rely on broadcasting, but you've got to get that information from another router. So helper addresses for what we're doing is related to the router for DHCP, but you might have to use helper addresses for TACACS and there's a couple of other types of protocols that rely on broadcasting, and you might have multiple hops. Okay, so how do we know where to put our helpers? Okay, so you use a helper address when the server is on a remote network. Now you all picked up on the fact that a server for DHCP might be a physical separate device, right? Like that's what we have in our Cisco lab. We actually have a physical separate server, but I could use a router, right? We can make our router function as a server for DHCP. So basically what we're doing is we're taking a little piece of its memory and a little piece of its CPU, and we're telling the router, you're going to behave as a server. We want you to function as a server. Okay, so the interface on the router receiving a broadcast must be configured with the helper address. The address of the DHCP server is the only parameter. Okay, so let's look at what that looks like. Let's see, is the address of the interface, okay. The IP, so if you look at these two, the interface on the router receiving the broadcast is the one that gets the helper. So another way to think of that is the IP helper address is the address of the interface facing the client. Facing the client, okay? What LAN needs help to get this address? That's the interface that gets the helper command. Okay, that's the interface that gets the helper command, because it seems like, you know, sometimes it's like, where do I put this helper? All right, so here's my server, which again could also have been another router. I need to get an address, so based on what we just read, which one of these, where do I put the helper command? G00 on this router, right? Because it's the one that's going to need the help. Right? It's getting this broadcast, and it's going to have to figure out a way to push that information to another hop, which normally we don't do any broadcasting, right? We don't do any broadcasting. So here's my relay agent or my helper agent. Okay, it's going to do the physical work. Okay, here's where I'm going to put my helper command. And again, it's real easy. This isn't a hard command. And the best way is just to be looking at your topology. Okay, this is the one that needs help. Where do I have to push that request to? I need the relay agent to relay the message to my server. IP helper address 192.168.11.6. Now the routing tables can start to do their work. And we no longer have to rely on the broadcast. Does that make sense? See, because over here, right, we're going to have route tables. We don't really have like a DHCP table that's keeping track of where DHCP servers are and stuff like that. So this one is the one that gets the helper command. The relay agent does the work. Okay, make sense? Okay. There's that. True or false? A router does not forward broadcast messages. That's true. That's why we need helpers. That's why we need helpers. Okay. When is there an exception to this as it relates to a DHCP? It's not necessarily an exception, right? I mean, it's still not broadcasting. It's just that we're helping that information move across the network. We're helping the message move across.
So without that helper, it's not going to work, right?
Nothing will work. Nothing will work. So, you know what? Let's go back. So now, so let's look at this, okay? So here, we've got the DHCP down here, whether it's a server or a router, it doesn't matter. So I have to put the helper, and let's put this, let's make this 192.168.11.6. Okay, so this one's facing the client. So again, G00, so it would be interface G00, IP helper address 192.168.11.6. Would it work? Because? Right, right. Okay, so in this scenario, we need to also add a helper right here. We've got to get, because we have this whole other network. So this is facing what the client would be. So this one also needs a helper. So this would be whatever it is, interface S00, IP helper address 192.168.11.6, right? Because it's facing the client. It needs some help. Yeah, so again, our network isn't that complicated, but okay, because we go just our DHCP server, I think is this one, if I remember correctly, or maybe it's this one. Oh, it's this one, and this one's trying to get the address. So it's a little more straightforward. Okay. But it wouldn't be uncommon to need 4 or 5. Every hop would need one. Every hop would need the helper. There's our helper address. Oh, okay, so here's a couple of other protocols that use broadcasting, and if you've got like the NetBIOS on another server or the TFTP, right, is on another router, you would have to use a helper address. So these are all dependent upon broadcasting. But again, I might have my DNS server 3 hops away, 4 hops away. So those are just some others. Again, you don't need to know that for the CCNA. I just like to add that so it adds understanding that a helper address is not really just associated with DHCP. Helper addresses are associated when there's broadcasting that needs to happen to another router and we can't broadcast. True or false? A router can be configured as a DHCP client. True, true. So what does that mean, Chase? If it's a client. Right. And how would the router get its address? This one, the client. Yeah, dynamically, it would do the same thing. It would make a discovery. It would do a discover. Okay, so everybody understand what that's doing? So here's my router. Okay, and it is going to, it's got this interface here, okay, and maybe it's connected to another router, and this is the DHCP server. For whatever reason, this interface is dynamically asking for an IP address. It's not static. So why would that, I mean, why would I ever do that? To me, that sounds like a nightmare waiting to happen, but there is a scenario in which that would maybe be appropriate. It's actually a couple scenarios now that we have cloud computing, but
Would it be, in the notes it said a small office?
mm,
You would use
well, what does it say? Does it?
a router could be configured as a DHCP v4 client in a small office, home office.
Okay. So I think what that's saying, I could be wrong. So the only real scenario that I am aware of where the router is a client is when the ISP is assigning addresses. So the ISP will randomly through DHCP will be out here randomly assigning these addresses. Now, after it assigns them, it'll make it static so that it doesn't keep changing. Okay? So because an ISP, they might literally have 1 million customers, right? And so like these days, I can go on to CenturyLink's website and I can just sign up for internet service, right? And so what will happen now is all that's been automated. And so it is what ISPs do. ISPs will assign an address dynamically to their clients, which is on my router. My router is their client, right? That's the only scenario. Otherwise, if you set up your router and you have it getting an address dynamically, what kind of problems could that cause? Exactly. This is the default gateway to a network, so then what? If it changes every day, you have to go in and manually change your default gateways on every device in your house. So that's why it's incredibly impractical for most solutions. The only time it would ever be used is, again, when the ISP is trying to dynamically assign it to, a gazillion hosts, which, a gazillion end devices, which in their case is the router. Okay. This is true. Would be assigned dynamically. Again, just a bad idea overall. To configure it, you use the IP address, DHCP, and then the interface. All right. IP address, DHCP. I have never seen this done except when I worked at CenturyLink. CenturyLink did this for their client, all their customers. Our wireless routers are all set up with DHCP. That's why when you walk into your house, if you have your cell phone automatically connect to your wireless network, it will get an IP address from your wireless network. It'll come off the Verizon. Like my phone, I mean, even right now, are any of you connected to the school's router wireless? So when you come to school, so what it does is it's going to the wireless access point and it's getting an address through DHCP. Well, when I go home, my cell phone connects to my home router, so then I get an address from my home router. Okay? But right now, I'm actually not connected to the school's network. I'm connected to Verizon's network. So Verizon is dynamically assigning me an IP address through their DHCP server. Okay. All right, so that's it. It's 4:30. I'm going to give you time to work on labs or your skills project. Nobody leaves early. Everybody needs to be working on a lab or a skills project. And when you come back on Monday, I want you to have, I'll say it again, Wyatt. I want you to have the DHCPV. I was just saying, when you come back Monday, have the DHCPV6 part filled out. Or today, okay? Can I see your OSI model? Looks good. Let's see your OSI model. Looks good. Is that because you don't know them or you just haven't added them yet?
I was thinking of them, I forgot them.
Don't send pets for beer. Does that help you? No, it doesn't help you, or it does help you. Data, segment, packet, frame, bits. Don't send pets for beer. Thank you. Next week we're doing Slack. So read that module, right? Slack's not it's easy, but you really got to read it because it's different than DHCP-v4. So you want to make sure you know the 3 different types of IPv6 dynamic host configuration. There's 3 different types. Make sure you know them. And you need to know what an RA is, a router advertisement, all that good stuff.